how do we want to, I mean, do we want to continue to kind of go over the issues document? Of course, we kind of already went through most of it yesterday. We can kind of just finish that and then do kind of branch off from that, or what's?
Well, we didn't. Yeah, I think in detail, we only went through like 4 or 5 points and then rushed through a few. But
right.
yeah, I think the bigger discussion points were left open.
Okay, so then that's...
Yesterday felt like more like a first exploration call,
right.
and maybe clarifying some of the core like baseline questions, but not anything related to the implementation.
Right. Yeah. Then let's just pick off where we left off yesterday, and pick up where we left off. So, who shared their screen yesterday? Was it Micah? Was it you? Who I forgot.
I think it was Micah. It wasn't me.
It was me.
Would you be willing and able to do that again today?
Sure.
Awesome. Then I think, Alex, you have like a better overview exactly of which point we discussed in what detail. So if you just want to then take it from there and kick us off, that would be nice.
Yeah, I just need to exit the full screen stuff. Zoom did. Okay. Yeah, so we skipped point 2b. So it's right in the middle there.
Right, the collision resistance.
Yeah, so just, yeah, an issue with the translation map is if you try to, I mean, basically fit in like a long address into a short one in the translation map. I mean, one of the main goals of the long addresses is just to increase collision resistance. And the second goal is to maybe have a field for an epoch. But yeah, I guess address space extension was proposed maybe initially really through the state expiry as a dependency, but then there's also an argument made that it should stand on its own just to increase collision resistance in Ethereum. But the translation map itself has this problem that it definitely increases, I mean, address space extension increases collision resistance within long addresses. But if your translation map, you decrease collision resistance within the short addresses because you keep adding more short addresses, which are part of the translation map.
Right.
And I guess this is a bigger problem if you have a long-term translation table, but maybe if you have like an ephemeral table, maybe the issue is a bit different.
I mean, it seems like it's an issue nonetheless, right? Like if you have I don't know, some DeFi smart contract smart contract that is deployed on the new address space and everything behaves well, but then it also interacts with some old DAI token or whatever, and it has a balance in there, and then all of a sudden you can deploy a different attacker contract that, of course, if you were the person that found the kind of the birthday attack collision and so kind of like also deployed this honeypot first contract, and then you can just deploy your attacker contract later and clear out the balance of that other contract in an old token or something. That seems like a really unfortunate situation. And it seems like it would be possible, like even easier in a sense with the ephemeral table, because there you wouldn't even be able to detect it because you keep no track of all conversions. Whereas if you have a permanent persistent kind of table, then at least once the honeypot address is in there, you can be certain that you can't override it in a sense.
I guess it also depends on how the ephemeral version works, and I guess this problem also depends on how the compressed address is calculated.
How do you mean that?
So if you look at the how to grind for the collision, as part of what, I don't remember what's the EIP number. As part of the having a address, which is a contract address, but also has an EUA key.
Oh, you mean
remember
the
that EIP?
reject transactions from senders with deployed code?
Yeah.
Mhm.
There's a linked document there explaining at least the current best practice to try to grind for that. And that also depends on, I mean, you can make it more hard to do that depending on how, one of the addresses you're grinding is created. If so this problem, I'm talking outside of the address space extension, just for the regular keys and contracts, this problem was much less pronounced with old create, because you also had a nonce and you couldn't just infinitely increase the nonce. So you would have needed to create new sender addresses. So it just involved more hashing, which made it really infeasible. But with create 2, you don't need to do hashing twice. You don't need a new sender. You just need to bump the salt. So basically a nonce. And the same way, depending on, if you have like a double hash in the compressed addresses, then it's at least with the technique described in the EIP, it's not feasible to create a collision, at least today.
Wait, how's that not just a 2x slowdown for like 2 hashes instead of 1? Or am I misconceptualizing something here?
What is
I don't
the
think
second hash? And
so. In
I thought it
the
was a part.
in the EIP, I
ahead.
don't think it's just a linear process. They're using some other trick to build up. I don't fully remember, but it's much more optimized than just running multiple hashes.
I see. Okay. Okay, so we can try and make it more collision resistant.
At least
Micah,
harder
I have
to.
two.
Sorry, Micah, go ahead.
I have 2 questions. One, why is the 80-bit collision resistance instead of 160? This might be
I
a
think
naive,
that's
simple
because
question.
of this birthday tech thingy, where basically you don't like it's 160-bit if you try to kind of like find like a collision with my address, where basically you pick one that's really kind of like you want to attack, and then it's 162 to find the collision for that. But if you just want to find like a random collision between any 2 addresses, then you can basically come from both ends at the same time, kind of like a birthday tech situation where, yeah. So
really
so then
drops it
it's
by half.
That's my understanding, at least.
Okay, I mean, if cryptographers say so, I will believe them. I'm just surprised that it drops the collision resistance by half.
In the link document in the EIP, there's a description of that. But basically, if you control what address you are, I mean, if you're in total control in generating this collision, and you're not trying to create a collision to an existing address, then that's the case. But yeah, just creating a collision to an existing address, that's still close to 160.
And this takes into account the fact that you can't realistically store all of the things you've generated along the way.
Yeah, I think so.
Like if you actually generate like keys until you find a collision, you're gonna run out of memory long before you run out of CPU power.
Yeah,
start dropping things.
Yeah, so there's a fancy cycle finding algorithm. So you don't actually have to store things. You just like have a system where you start at one address, you then randomly jump to another address, and if you've ever found a collision, the whole thing will come around in a cycle, and you'll end up, and you then detect this cycle, and eventually you like then look around the cycle and find the 2.
Okay, so fancy math and algorithms gets around that problem.
Basically, yeah.
I accept that.
So and then, but do we have a good understanding how easy it would be to make a translation map, like easily make a translation map resistant enough so that it'll kind of like buy us many more years of collision resistance without making it like very inefficient to use normally for normal kind of usage inside the EVM?
Well, I'm not a cryptographer, but it seems like if I mean, just a really simple option seems to be like using just a double hash for the compressed address. That would make it significantly harder, but yeah, I guess proper input from a cryptographer would be the best approach here.
Right. And also, of course, important to note, I think yesterday we talked briefly about how if we could kind of make compressed addresses be easily distinguishable from just normal legacy short addresses with like an extra prefix or whatever. And that would kind of like, of course, completely give up on collision resistance, because that would have to well, not completely at least, but it would make collision resistance like in a significantly bigger problem, because we would have to give up on several more of the bytes of the 20 bytes. So then it's maybe 17 bytes or something of an extra compressed hash.
Yeah.
Does the translation map actually reduce collision resistance at all, or does it just leave us in the same spot with regards to collision resistance?
I think it makes it worse actually, because well, it has the potential at least to, because on normal mainnet right now, you really only have a problem with counterfactual contracts. So like once something is deployed, you're safe basically. And I think we kind of lose this property potentially. At least kind of depends on the specifics of how we do translation mapping and everything. But we. Mm-hmm.
You're assuming that we go forward with the EIP that doesn't allow transactions from a account that, or from an address that has a contract deployed.
Yeah, I would be very certain that we have that in place before this ever becomes a problem.
Okay.
But yeah,
okay.
Yeah. Without that, of course, you're right.
Okay, sorry. So you were saying that this makes it easier, basically. Like,
well,
to find
it depends on it. No, it doesn't make it easier to find collision. It makes it easier. It could make it easier to exploit that. Depends on the translation map specifics used, and also, yeah.
It just introduces a new way to do that. So you can
right.
you can create a collision in the translation table compared to, so the whole problem with the translation table is, okay, there are multiple facets to this, but just one facet is that from legacy accounts, obviously the what you mentioned is there's no way to distinguish whether an address is a legacy or a compressed address. And then from a legacy account perspective, if something is in the translation table, they can only access the translated version of that account. If something is not in the translation table, they can only access, whatever that short address refers to, and they have no means to see if that is an actual account, or that's supposed to be a compressed address or not, etc. And then that's the I guess from the new account perspective, we may be able to introduce like ways that the new account can access both of all of these different accounts. But the legacy accounts, once something is in a translation table, they can, and they made a transaction before that and created an account that way. Once it is in the translation table, they won't be able to ever access it. And that's why also this translation table introduces like another surface for the collisions, because one may be able to create a collision in the translation table, even for another existing address, a legacy address. And in that way, they would make legacy contracts interact with like a given address with contract X, Y, the new namespace would interact with a different contract looking at the same address.
Right. So basically, instead of only having to worry about collisions between two legacy addresses, now we also have collisions between a legacy address and a translation map entry, and collisions between two translation map entries. So these are kind of like now 3 different types of collisions instead of 1. And it's at least somewhat tricky, I think, to get all of that right in order to make it as kind of unexploitable as possible. Ideally, it kind of like, I mean, there's, as you were saying, there's just no way around it, that at the end of the day, this is like only 80-bit collision resistance. We can make some of the hashing kind of like be a bit more, kind of make it a bit harder or something, but like this won't be resistant forever. Like at some point within the next decade or so, or maybe whatever, like it will be feasible to, at least that's my understanding, to cause kind of collisions somewhere.
So it's currently feasible to cause collisions. It's just extremely expensive. I really think off the top of my head, but it's going to be like several months of Bitcoin mining worth of computation just to generate one collision. But it is technically feasible today if you have like almost state actor level of money.
Right. Okay. And also like today, well, as soon as we have the CFP, it only affects kind of counterfactual contracts. And so, yeah, if you have a couple $100 million to spend, you can do it today. This number, like as we were discussing, this number could go up for the translation map if we kind of design it in a way that cryptographers are happy that it at least makes it somewhat harder. But I think at the end of the day, it's like, I think there's only so much you can do. It's only 80-bit. Like there's no way around it, at least in my understanding. So while we can make it more expensive as like a one-time protection, that will just continue to drop in price over time. And so if we want this to be kind of future compatible for a long time, I don't think we can like completely prevent that. Just as we will continue to have legacy addresses, and those will continue to be more and more like susceptible to collisions. So like if you continue to use counterfactual addresses in the legacy space, at some point you'll be easily attackable. And if you continue to interact with the kind of legacy world, at some point you'll be easily attackable with kind of collisions here as well. And the question is just, what's the scope? Like if we can we make it, for example, that it's also only like a problem for counterfactual kind of contracts? Is it only like a problem for legacy contracts? Is it a problem for all new contracts that interact with legacy contracts? Like basically just trying to really understand the exact threat model here. I think it is also important.
It seems that the best we can do is to at least ensure that the I guess the ATAC surface described in this other EIP, we avoid that ATAC surface with the translation map. And whether it's like with double hashing or whatever other means, it seems that at least avoiding that problem is possible. But if any other technique would come around to create a collision, or just the sheer computational power increase or storage increase over the next years, I guess you cannot really make any fight against that today. So the best, I guess, what we can do is just make sure that the problem described in the IP cannot be replicated here.
So while we could double hash, triple hash, quadruple hash, keep in mind that will increase the gas cost of putting things into and verifying things in this translation map. So it's not a free trade. Like it's not just like we can just hash it 72 times. Like we can't just do that. Like if we want this to actually be usable, I'm pretty hesitant to double the gas cost of this, getting things into the translation map.
I mean, it's important to note, right? Like 2 hashing isn't a double cost, because most of the cost of adding something to the translation table would just be like adding a storage entry. So that kind of like vastly outnumbers the cost of the hash.
Do we do this hashing anywhere else? Like, or do we have to do that conversion any other time other than when we're adding to the translation map table?
No, you just need to do once in order to insert it. But that insertion can be triggered by different opcodes or transactions. But once it's inserted, it's there and you don't need to do it again.
Wait, but don't
So I'm
you kind of
assuming-
like have to do the conversion every time? Like, say I'm inside of a new contract, but when I'm already in the translation table, and now I call into a legacy contract, like because the mapping is only the other way around, I feel like my address will probably still be manually converted again. So every time I call into a legacy contract,
Yeah.
my address will be converted.
Yeah, but if you call in from a long address into a legacy contract, then the translation table is populated by that entry.
But is it
No, but it
two-way or is
isn't.
it one-way?
I think it's one way.
So
So
whenever
it's only
you
short
are-
to long, not long to short.
Yeah.
yeah, but why do
Yeah.
you
So
need
which
long
means
to short?
every time you start with a long and you want to, even if you're already in the translation map, you start with a long, you need to find the short, which means you've got to do the derivation again. And then you look up and see, oh, we're already in the translation map. So you pay for the nest load and you pay for the cost of actually doing the conversion.
But like 2
and
hashes
so-
is really just like 12 gas. So it's insignificant
Is it
compared
really
to,
12 gas for a KCAC?
yeah, it's a single
thought it was
word
like
what we
100.
need to do. No, it's not. No, it's pretty low.
Okay.
Yes, I feel like there can be, I mean, that's the point where we would have to also kind of like talk to cryptographers just to make sure like what's the minimum effort we would have to do to make it more resistant. And if it's really like one additional hash, I think that shouldn't be an issue. If there are other things that would be required and it makes it more expensive, then at some point this could be a trade-off that's just not worth it. Yeah.
The problem is that like all of these sorts of techniques, you're effectively doubling the cost of using the translation map to double the cost of like attacking the translation map, which like ultimately doesn't like achieve that much because you want to use cryptographic techniques where the cost of use is really low, but attacks are really expensive. So I'm not convinced we're massively gaining anything here.
That was my question in the beginning, because my understanding in the beginning was that there's a linear relationship between increasing the cost and increasing the, like cost for attackers and for ourselves. And like, but the way I understood Alex was that with like a double hash, it would completely make this specific implementation of a birthday attack impossible. And that would be a different thing, right? And so I don't know how that would be, or like why, but I just don't have the understanding. Like the
Doesn't it just get us from 80 bits to 81 bits effectively in terms of cost?
Yeah, that would be my understanding. And then it seems like it's just not worth it because you only have a linear kind of lever here. But if it gets us, like if it completely removes this 80-bit attack vector at all, then of course it would be worth it. I'm just not in a, like my naive understanding would have been that like birthday attacks always half the kind of the like not half, like basically like logarithmically half basically. So like get us from 160 to 80 basically. But if of course that's not the case, and this 80 thing is just like a specific result of the way we do it today, and we can trivially change it, and this complete kind of approach doesn't work anymore, then I'm on board. But yeah.
So it is just that the birthday attack square roots the cost of doing the attack, or equivalently halves the number of bits of security you have against a collision attack. Just to put this in like perspective so we know what numbers we're talking about, the entire Bitcoin blockchain in like its history of like difficulty has performed 2 to the 90 SHA hashes in order to do the proof of work. And this attack requires 2 to the 80 SHA hashes. So you do need a lot of money.
Right. Yeah, no, that makes sense. And so, I mean, I feel like probably makes sense to more or less like quickly move on from here. But basically, the point is like, it's kind of an open question. Is there an easy way to make kind of like collision, like finding collisions much harder? If there is and it's cheap for us to do, then like all the better. But like if there isn't, then we just basically have to deal with the fact that this table won't be like is in practice collision resistance today because we don't have kind of state level actors who spend years trying to cause one collision on Ethereum, but might like 10 years from now be feasible for a very motivated and only moderately resourceful attacker.
I'm very uneducated on the cryptography side of things, but my gut says that we should move forward with the account address extension, and with the knowledge that we only have 80 bits of collision resistance specifically for legacy contracts, and we just actively encourage people to move to the new system for their own security. Like, just get people off of legacy contracts as quickly as we can. I think that's our best bet.
So I also would say we should focus on trying to kind of like decrease the amount of damage you can do with the collision, because that's like, I feel like there's a lot that can be done. Just design it in a way where, like, similar to how today you can only exploit counterfactual contracts, and that's kind of fine. And so make it so that in this new system also, like, the damage you can do to the legacy world is as limited as possible for collisions.
I think the thing here is that you like fundamentally can't beat EIP 3607 protections. Like, if you are dealing with the counterfactual contracts, like fundamentally, and you're using 160-bit addresses, regardless of whether they're compressed and they like go into translation map or whatever, you just can't win. This attack can't be performed. I think the design goal we have to keep in mind and make sure we achieve is that we need to not open attack vectors against collisions involving non-counterfactual contracts. So if I have a 160-bit address that refers to a contract that has been deployed on Ethereum, that reference must be valid and must point to that contract, even if that contract has a collision and it could point to a different account. And it's very easy to see that there could be translation map attacks where, for example, I create a contract that has a collision. I create a legacy contract where I also have a long address whose compressed address clashes with that legacy contract. I deploy the legacy contract at some address, the address. People start interacting with the contract, do stuff with it. I then deploy the long address contract, and the long address then creates an entry in the translation table, doesn't check whether there's already a legacy account at that address, sticks that in the translation table. Then future people trying to interact with the contract are instead interacting with the new long address contract, and I've effectively clobbered the legacy contract.
Yeah, but there are problems here. So and those, I think, mostly, like, there's several kind of like details to get right. So for example, what about a long contract that has already been deployed but is not yet in the translation table because it hasn't yet interacted with the legacy world, and then tooling for users might kind of somewhat carelessly already allow them to send funds or something to the compressed address, tokens or something, because they assume that it will be converted sooner or later or something. So this would be like just a kind of like a nuance that we have to be careful about. But then the more important point, I think, here is that this is really hard to get right once we introduce state expiry, right? Because if a address that collides with the compressed address has it already expired, we don't know that it existed. So then all of a sudden, either we have to be fine with collisions where one of the party of the collision is just expired, where we say, yeah, like if you don't want to be target of collision and you live in the short address space, then you just have to make sure you always kind of keep in the active trees. Like, you have to just use your account once a year. Like, otherwise you could be like, not your own account, but like, because if your own account, like, that could be the target of a birthday attack. But like, if you use like if you basically have funds with a legacy address or of some sort, then you just have to make sure you use that once a year, because otherwise it could have been set up as a collision thingy, and then once it expires, they can create that collision, and there can't be a check because it expired. It's not part of the active state. The other alternative would be to like require an exclusion witness every time you add something to the table, but of course that's just not feasible, because then, yeah, I mean, self-evidently not feasible.
Does this problem go away if we just disallow creation of legacy accounts once this launches?
I don't think that's related at all.
What we're
Um,
talking about, these attack vectors we're talking about, is someone creating a legacy contract that collides with something in the translation app, right?
But you
Yeah,
could do
well-
that with an existing deployer contract. Like if you already have a deployer contract on the chain today, we can't break that contract, and so we would have to continue to allow
see.
deploying new child contracts.
But there are also
The-
multiple parts to this collision. I mean, well, the bigger risk is creating collision for, I guess, based between a legacy address and the compressed address. But we also have this other part where you could try to grind two long addresses which result in the same compressed hash or compressed address, right?
Can we just disallow that? Like,
Right,
if you're already in
but the question is,
translation app?
what does it mean,
How?
disallowing that? Yeah, so basically what you would have to do is, like, every time you try to add something to a translation table, but it already is in there with a different entry, you would have to you'd have to completely throw, which could be fine. I think
Yes,
that's the best way to go.
Like the chance of someone running into this on accident is basically 0, if I understand correctly. The only time you'll run into this collision is if you're actually actively an active attacker. I'm totally fine with just hard throwing on you and just being like, nope, whatever you're trying to do, you cannot do it. I don't care what it was.
Right,
it
but
doesn't
but
work.
But you just
again,
mean
there's-
specifically the translation map and not in general, because in general you cannot disallow addresses. This
right,
Yeah,
it's only the translation.
This would be just specifically for as soon as you try to get added to the translation map, if there's something already in that spot, like so there's already a short address, a compressed address, sorry, in the spot you're trying to add to, we just hard fail on you. Like it just doesn't work.
But also that
whatever.
comes with problem of its own, right? I can find a collision between two potential contracts that I can then deploy on like long contracts, and then the first one is basically some honeypot or whatever that has some payout functionality that runs through the legacy Uniswap, right? So if you want to withdraw your funds, it calls into the legacy Uniswap and then it converts whatever and then it sends it out to you. And that's the only way to get your funds out. But otherwise, it doesn't touch the legacy world. And so it's not yet in the translation table. And then you deposit funds because you audited the code and it looks nice. And then before it ever touches the legacy world, it gets added to the translation table. I then deploy the other one that has the same compressed address, interact with the legacy world, get added to the table. And then whenever you then later on want to actually do the withdrawal, and for the first time ever touch the legacy world, now the withdrawal always throws because it can't get into the translation map anymore, which is, of course, you can prevent that by making sure you only deposit once it's added to the translation map, or you could even have a like access list thing where you can just already add it to the translation map before you need it, just to make sure it's in there, these kind of things. But it's really hard to get that right, of course, from a UX perspective, right? That your tooling always ensures that happens. It's like we don't want to only find a solution that works in theory, like it has to also work in practice. And I'm a little bit worried that this is really hard to get to consistently get right in practice.
Yeah, I'm then back to just tell people to get off of legacy contracts as fast as possible.
Yeah, I mean that's
right,
I think that would be the main goal, to have incentives right so that people move on to the new space. It's just for two reasons. One, to just keep this translation small. And also, I mean, that's the way people are going to have more collision resistance, and that's the only way they could have something like epochs. So it's really just a matter of how can we incentivize people to move, and
you will lose all of your money if you don't move.
Yeah, I think it's kind of hard to incentivize them though, because I guess the main benefit of DeFi is the composability, which is really biting us back in this case, because you cannot really easily move like the lower building blocks over, unless the upper, anything building on those have the capability to
Well-
to work with any
Yeah, I mean,
the new space, right?
We see the level stuff upgrading all the time. Like Uniswap has done 2 upgrades already, and they're
But
basically
Uniswap
they're a pretty
isn't
low
low
level building
level.
block. Yeah, every
Yeah.
contract uses Uniswap. Like they, not every, but lots of other DeFi things refer to Uniswap, directly tie into Uniswap, like hook into Uniswap, call Uniswap. Like that's a very
Yeah.
common pattern. And
Yeah, I mean,
they
just for
basically
simple
say we
exchange,
upgrade.
but yeah, but I mean more like all the tokens and all the different pools. You know, there are a lot of interdependencies there.
Yeah, I mean, I agree.
I mean-
it's not trivial, but like over the course of a year or two, if we tell people, hey, you know, this isn't enough security, you need to get off of this, start working on that. I think the DeFi ecosystem will figure it out. Like the
So the
low level stuff.
But do you think
we'll force
the
it?
security, just using security as a reason, when then somebody can argue that it takes maybe like 8 years of computing power spent on Bitcoin to do this, which may make
But-
sense, if enough money is locked up. But do you think the security
Yeah,
aspect
but
is enough to
that's the
convince
point though.
people?
Like it doesn't have to be quickly to happen quickly. Like the whole point of this is that 10 years from now, maybe it will be kind of like feasible for non-state actors to do this kind of attack. So within the next 10 years, everything should have migrated over, hopefully. But I'm really optimistic about that. I'm not so optimistic about 1 year. Like the moment address space extension goes live, it'll not all projects will be migrated over within a week. And not all projects will be migrated over within a year. And probably not even all of them within 2 or 3 years. But the point is, we have this nice, that's why our solution has to be really kind of seamless to kind of like forward compatible, right? Where basically you can start migrating over some things and point them to the legacy world and they just continue to work. Because if it's really like a big problem from the get-go to interact with the legacy world, that's just a non-starter, because then everything will continue to live in the legacy world for compatibility. But if it's really seamless to just deploy your new Uniswap v4 in the new world, and then like the upgraded, I don't know, USDC token is in the new world, and then the upgraded next token, and like over time, all of it just more of it moves over to the new world. And so the nice thing is that with state expiry, kind of like we have a gradual ramp up of incentive to move, right? Because the legacy contracts will become more and more expensive to use, at least if they
But I think
occasionally write.
you really misunderstood what I said, because I mean, if this interaction between the two different sides of the accounts, if that is not seamless, then it is not going to happen. It has to be seamless.
Yeah, that's
Otherwise, yeah. But I think my main question is: do you think just saying that, oh, because of security, you should migrate? You think that's enough? I don't think that's enough. But then,
on what timeline? It's not enough within a year, but like
even like a 3-year
it'll-
timeline, I don't think it's enough. And my question is, whether what is more incentive? Okay, I mean, state expiry is a different question, and when does that happen? And when it does happen, I mean, that definitely puts a bigger incentive on it. But before that, I wonder which is a bigger incentive to get penalized in terms of gas if you stay in the legacy space, or rather get like gas benefits if you go to the new side.
I don't think we should be like opinionated on that at all. Like the Ethereum kind of pricing should always just kind of correspond to whatever.
Well, there are
actual
gas prices for all of
Well,
these features, so
I think
that's
what-
opinionated.
Yeah, I think what Alex is getting at, correct me if I'm wrong here, is that if we require the translation to be like 72 hashes or whatever, it means this will be expensive but more secure. And so that would incentivize people to leave because, hey, I can get cheaper.
The opposite actually. If it's more expensive, then it means it's more expensive to have the new contracts that interact with the legacy world. So what people will do is they will continue to deploy exclusively in the legacy world, because that's where all the things they want to interact with live for now. And so we have to make it the other end, like really, really cheap, so that like people, the point is, I think it's obvious that no one will continue to deploy things in the legacy world unless we add unfortunate incentives otherwise. So like in the default case, all the new things will be deployed, right? All the new Solidity versions will be compiled
why
for the
would they?
for the long.
Well, first of all, people don't use recent Solidity versions. They're always like through 2-3 major releases behind.
Yeah,
And
I can confirm that,
auditors
by the way.
auditors like strongly suggest to use something like 0.5 at the most, because they claim that newer versions are more buggy.
What?
So yes, but
There's really
in any
auditors
case-
that are recommending 0.5.
yeah,
Oh my god, there's so many security enhancements in like the newer releases, like checked math, for example.
yeah, nobody recommends 0.8. That's just too
Oh
new.
my god.
It takes like 2 years to
Right.
get. So maybe next year
But
we're gonna see
even-
like 0.6 as a recommendation.
Even that seems fine. So for one, I feel like with the, just coming back to state expiry for a second here, I think it's important to note, like we will only go ahead with the expedited address space extension once we have like the full state expiry kind of based on it in place. Like there's no need to rush address space extension unless we need it for state expiry. So the moment address space extension would hit mainnet, I would feel very confident that the old state, like the Merkle partition tree, would expire within a year from that point. So within a year from the address space extension, we would start having actual incentives pricing wise for people to migrate. At the same time, I feel like with a lot of these concerns around like collision resistance, we only have to make sure people migrate on a 10-year timeline, because that is kind of like where concerns become realistic. We don't really like it. It doesn't matter that much that it happens within a year or two. That's just not the tech model here.
I think
Yeah.
you're talking about entirely different things. So since there is no way to reject legacy addresses from being created, at least well, we haven't discussed that, but there doesn't seem to be an easy way to reject legacy addresses to be created. Maybe after
we
state
could if we
expiry it is, but right now it isn't. And
I thought we
because
could if we did the contract prefix thing. Am I incorrect?
The what?
but
Alex's other EIP, I don't forget what it's called.
yeah, but the problem with the, there are a ton of like balances which exist as only in tokens and not in the state.
Yeah, counterfactual contracts basically that have.
I mean,
yet
not just
been deployed.
counterfactual, just people having a token but no
Oh
address
yeah,
attached to it.
counterfactual EOAs basically.
So, sorry, I was
Right.
saying, like, can't we prevent people from deploying contracts that are at legacy addresses starting at some point? I thought that was a thing we could do.
Yeah, but
with
that
the-
breaks
what's it called?
compatibility. Like that
Whatever.
actively kind of like breaks things. So we don't want to do it.
So
It
Also, I
breaks
don't.
things.
Maybe just taking a step back. So assuming we cannot prevent, for the next 2 years, let's just assume, before state expiry, we cannot prevent new legacy addresses from being created. And then we already also
Right.
introduce this new long address address space. And if you want to interact between like a long address and legacy address, you need the translation map, right? But you still have the ability to keep creating legacy addresses. What is the incentive for people to start using the new namespace and not just keep using the legacy space? If they keep
Well, that's
using the
easy.
legacy space, if they keep using the legacy space, they never go to a translation table, so they don't really have any pricing difference or anything.
Well, no, but like that's exactly where state expiry comes into handy. Like it'll be as soon as we are 1 year from the address space extension point, and I think that's only fair also because it gives people
2
some
years, I
time to
think.
kind of start, to start migrating or whatever. But once we hit that point, all new creations on the legacy side will have to come with witnesses, and I think witnesses will just be really expensive, especially in the beginning. So that's a strong incentive to no longer like there won't be an incentive for the first year basically. Well, there's already an incentive because if you deploy in the legacy space, it'll expire as soon as we reach period 2. Whereas if you deploy when we like so just for terminology here, so the moment kind of like address space extension would go live, that would be part of this hard fork where we also move to period 1. And so if you continue to deploy in the legacy space, you continue to deploy at period 0 addresses, because in the legacy space there is no period 1 address. But if you deploy on the period 1 side, you deploy period 1 addresses. Period 1 contracts that you deploy will have free access to storage, not free, but like witness free access to storage guaranteed for 2 years, or like for basically for 1 year plus. Whereas on the legacy side, it's 1 year less. So basically, like the contracts that you deploy on the long side will be future proof for 1 more year for like witness free storage access. And I think that's a huge incentive.
It's only 1 witness a year though, isn't it?
So
No, it's 1 witness per storage slot per year.
But I specifically
Right.
said if we don't have state expiry and before state expiry, right? And there's just 0 incentive before that.
Right. But that's why I'm saying we should just not, we won't do address space extension, at least not this kind of expedited version of it. If we don't do state expiry together with it, this proposal will not hit mainnet within the next 3 years.
So
4
what do you mean
years.
by
Yeah, so-
expedited?
Well, like the point was that people were like saying we kind of have to do just address space extension because of hash collision issues, and so that is a medium-term concern. So we have to do it within the next 5 years, and it is also really helpful for state expiry. And state expiry we ideally want to do next year. So if we want to do state expiry with address space extension will have to hit mainnet kind of basically next year. I mean, end of next year, early kind of 2023 would also be okay, but
Yeah.
this kind of timeline. So we'll only end up doing address space extension on this kind of very quick timeline of like 1 year, 1.5 years, if we actually have state expiry in place and we are going ahead with state expiry. There's just there's no world in which we go through all this hassle with state address space extension anytime soon, just to protect counterfactual contracts from collisions. That's
Yeah,
just
and-
not a thing.
To be candid, the only reason that I care about address space extension is for the state expiry. Like the collision thing is an interesting, like theoretical problem, and I agree that eventually it will be a real problem and we should solve it. But state expiry is definitely my number 1 driver for why I care about this at all.
Well, is there anyone
I like-
who
yeah.
was in
Sorry.
before the collision question?
What was that?
Is there anyone who is in who is interested in address space extension because of the collision issue? At least on this call, I don't think so. Everybody's motivated by the state expiry dependency.
I kind of suspect that is by far the dominant concern within
But also there's a bit of a selection effect here because the invites went out to this statelessness call group. And so that is by
Sure.
nature people who are interested in state expiry. So there could be the odd cryptographer out there that just isn't aware of the statelessness effort and so isn't on this call.
I think it's also the fact that state is a real problem for Ethereum today. Like this is a theoretical problem 4 or 5 years from now, but we have a serious state problem today that we need to solve as soon as possible. And so that's just is very motivating. Like today's like deal with tomorrow's problems tomorrow, deal with today's problems.
Right. That's why I'm like, I still think that it's a good thing. Like also like I like the way your team kind of did this proposal to keep the proposal separate from state expiry, because I agree that it's always better to develop these things as modular as possible. But for the purpose of thinking through the implications, I think it makes sense to do that in a tightly coupled way together with state expiry, because that's just like the reality of it. So like develop it independently, but for like thinking through the implications and the incentives and the behavior of people and all of this, I think it makes sense to do that in a context that assumes state expiry.
Well, we definitely hope to explore and specify this independently, because there's just so many changes otherwise, and even this seemingly small part has so many I guess, questions or new properties to discuss. But yeah, I mean, the incentive structure is basically non-existent unless you bring in state expiry.
Right, but I think that's fine.
Even then, to argue against myself, sort of, I don't actually think the incentives for state expiry are that strong. One storage slot witness per year is, well, witnesses might be a little bit spendy. Supposedly with Verkle trees, they get relatively cheap. And I'm not convinced that's going to be enough for people to care. Like I don't think that is actually a strong incentive. I don't think that matters, because I think that we can just like our job is to solve problems for Ethereum and think about Ethereum's long-term health. And we can do only so much to protect users, but we need to solve stateless. And in order to solve stateless, we need address space extension. In order to solve the collision problem, we need address space extension. So we have to implement address space extension.
We don't need address space extension to solve, statelessness, though.
I mean,
it's just ace. Like, I don't know if you saw the post. I mean, there's definitely a way that you can have metadata in the state trie or have a separate trie that's not expired. These are like definitely alternatives.
We should have a call about that separately. I'm not super convinced that those are actually pragmatically viable compared to the current situation. Like, if we have to decide between address space extension problems and those problems, I feel like the address space extension problems are simpler. Which says a lot, because I think they're very complicated.
To that in the chat, because Matt and I had Matt had a write-up on that just like 3 days ago, and I commented on that a little bit. And I tend to agree that, I definitely agree that address space extension is the cleanest way to do it. The clean only from the point of view of the state expiry, of course. Inside of it, there are a lot of messy problems, but like from the state expiry point of view, it's the cleanest approach. But I disagree that it's the only feasible approach. So there are definitely others as well. So like, we don't have to kind of like do address space extension no matter what against all kind of resistances.
Sure. So I guess let me rephrase. I think that unless someone can propose a solution to be here, the 80-bit collision resistance issue, I don't think that not being able to solve that should stop us from moving forward with address space extension. Like, I do not see this as a blocker. Yes, it would be great if we could do better. I have not heard anybody suggest any great alternatives, like maybe talk to a cryptographer and see if we can do multiple hashing rounds or something. We can investigate that. Maybe that'll pan out, maybe it won't. But I don't think that should stop us from moving forward, like with everything else. Like, we should, I don't see dropping this because of that. This is not a blocker, in my opinion.
Also, I don't even quite understand why it would even be an issue if no one migrates. Like, basically, the whole point is that we do like two things. One, we say we have this concern of the security, and like it's up to users to kind of decide if the security is worth the hassle of migrating or whatever. And if they decide that they don't care, then I mean that's up to them. And also at the same time with state expiry, we only want to make sure that it can continue to stay efficient and cheap to interact with Ethereum. And if people want to do that, then they have to go through the hassle of migrating. If they prefer to have more expensive, but kind of like more expensive transactions, but everything stays as it is today, that's up to them. That's fine as well. I feel like we should be completely unopinionated. We should just introduce a mechanism that starts making it feasible again to be a miner without storing an incredible amount of state. And so that's our job. And then how people choose to interact with what trade-offs, I really don't care. I don't want to nudge them in any direction. That's up to them.
Yeah, I agree. Like, we can give users the information and the tools to protect themselves, and they can willfully choose to ignore them like they always do. And I'm okay with that. Like, we tell people all the time, like the auditors and whatnot, we tell people all the time, don't do these things, and people still do them. And, bad things happen or bad things will happen. That's their choice. But as long as we inform them and we give them the tools to protect themselves, like, I feel like that's kind of the limit of what our expectation should be, or expectations of us should be.
Right. So I just feel like we should make address space extension the best way possible. And then, yeah. So sorry, Alex.
So it seems we spent the entire call on this point 2b, but Yeah, I think it was very useful to explore all these different potential collisions which could happen. At least I guess now everybody has a better understanding of this question. But yeah, I guess I could say like another 5-10 minutes as yesterday, but if we do that, I wonder, should we, I don't think we can discuss anything under point 3. So like the transaction access list, that's a bigger topic. But if we want to discuss something before we hang up, I think we could discuss like this point 4a, like EC recover, or I mean the EIP 3074, but yeah, it's practically the same question.
Yeah, I mean, specifically 3074, I think should be less of a concern because that's still actively being developed. And so whatever we kind of, if we start having a concrete vision for a state like address space extension, we as the 3074 authors would make sure it's forward compatible with that. So I wouldn't worry too much about the 3074 side of things, more about the EC recover. But to me,
well,
at least,
I do worry about the 3074 because, you know, if 3074 goes in maybe late this year, and it makes no preparation to be compatible with address space extension, then maybe we run into a case where it may be just maybe too hard, or like there may be just really bad ways to make it compatible, or maybe we will need to introduce yet another opcode.
Yeah. So then, like, let me rephrase that. What I'm saying is not like, yeah. So basically, I think it's important to raise this, and I don't think we have really thought about it much yet, as like with the EIP. But so basically, what I'm taking away from this is like a task for us: make sure that it's forward compatible with address space extension, and don't move ahead with the EIP before we are sure of that. And we will do that. We will ensure that. I mean, for one, of course, 3074 is very far from ensured to reach mainnet anyway. But like, we will make sure it won't reach mainnet in a potentially not forward compatible form to address space extension. So like, point taken, basically. And it's not like that requires extra effort. We haven't yet put that in, but we will make sure that, I mean, I want to bring address space extension to mainnet as soon as possible. I will not, like, on my watch, there won't be an EIP that adds complications to that. So
yeah, my goal wasn't just to make the point for you guys to work on it. I think it would be a useful and interesting discussion to be had, you know, under these calls. So
right, I'm just saying, like, 3074 is just still not, like, they're still kind of, it's still changing form kind of over time as people get feedback. And so I feel like, given that it's not yet part of mainnet.
Yeah, but the main point of it is, I mean, that's why the order is like this, that we have EC recover and then 3074, because 3074 basically does an EC recover itself, right? So whatever, if we explore this topic under EC recover, then we have a better understanding, and maybe that understanding can be applied to 3074.
Right, and also it's important to note though that like there were versions of 3074 that included giving the auth opcall the address that is expected as the signer. So like basically explicitly, just basically instead of only returning it from the opcode, just already passing it in and then throwing if the signature does not match that. And that version would be forward compatible because you could just give it a period aware address and then it only checks the hash bit of it. And so, but then it knows which one to actually set the authorization for, depending on that. And so there are a few different ways to make it work. But yeah, on maybe to start with the EC recover bit, because like also there's like for before we talk even about EC recover, just like I think we talked about this very briefly last time, the transaction format, where legacy transaction formats basically what they would have to do is just assume period 0 basically, or like even the legacy accounts and just send from there. But for like a new transaction type, you would basically, what you'd have to do is you'd also have to specify the period, right? So you'd basically give it the signature and the period, and then it would basically recover it as a signature from that period. Or I assume you'd also have to sign over the period. I'm not sure. yeah, it seems like you'd have to also that would have to be one of the fields that's signed.
Yeah, but it's again a very like state expiry specific view of it.
Why is that the case?
Because you only have periods in state expiry.
Right, but if we want to, like, if we already block 3 bytes or 4 bytes, I'm not sure what, I think 3, right? In the long addresses for a period number, even if it's set to 0 first, then we should have a transaction type that is forward compatible with a time at which this is not set to 0 at all times. So I'm just saying.
Yeah, I mean, in our respect, we don't block it for period, it's just reserved 4 bytes. Right, because the proposal is decoupled. But okay, can we just talk about EC recover?
Yes, please.
Before going into transaction types.
What is the problem with this first one? Why can't we just do this? Like, why doesn't this just work?
Which work? So anyway, the main problem with EC recover is
the first bullet point.
You mean the first question there?
Yeah, sorry, the first question. Like, why can't we just do that? Just have the precompile return long to new things and short told.
I don't think
none of these are kind of like, we can or we cannot do them. I think we can do all of these. But the question is, which is like a more pragmatic approach. And
so the first one sounds the best to me, just gut wise. Is there some reason that I'm missing that makes the others sound compelling at all?
Yes.
Well, if you do have state expiry with epochs, then you would need to account for that anyway.
Exactly. So that's why I feel like so I mean, again, I understand why you want to keep them separate in design, but at least to make it forward compatible. In some point in the future, there might be more than 2 addresses. Not right now. Basically, a signature with address space attention would, instead of 1, could resolve to 2 addresses. But in the future, it could be instead of 2, it could be 3, 4, 5, 6, 7, whatever. So we want to have a solution that is compatible in the world where it's n instead of 2. And so to me, that seems to indicate that we just need a new EC recover anyway that takes in some extra input. And like for me, in my aesthetics mindset, that would be the period number to resolve the address for. But there could be whatever extra information. If we end up also with a address type 2 and address type 3 or whatever, there could be other information as well. But like for now, in my mind, that is the period number.
So why not?
How does that work?
Why not just require why keep it as a EC recover as opposed to a check whether the signature corresponds to a given address?
So you basically mean you give the opcode a address and it only returns true false?
Yeah.
Well, the problem is that I think that kind of makes sense from a ease of use and security perspective. But the problem is that right now you can be very efficiently just only pass in a signature into a contract and it does all the things it has to do with that. And then in the future, you would always have to also externally pass in the address. And so that's just like 32 more bytes of call data you always have to pass along in addition to the signature. If we are okay with that trade-off, I think it's a practical choice.
So my only concern with the epoch is that, that isn't like fully future compatible either, because the address format, the new address format, is not like based around epochs, it's based around the version byte. And different versions may introduce like entirely different formats, which we may not foresee, right?
Right, but the nice thing is
we'll have to include at the least those reserved bytes. So the 4 bytes instead of all 32, though, you can just pass in the 4, and it's
no wait. I
doesn't
wouldn't
matter
say
what
4,
those
no.
are. Just
the 4 work with version 1.
Right, exactly. That's what I'm saying. I feel like what you should do is you should just pass in basically a version number plus whatever payload that version needs. And that for version 2 or version 3, that could even be the full address that it expects to return or something, and then it only does a check. But it should, I feel like an opcode that's perfectly future compatible. If it doesn't take in the full address and only does a check, what it should do is it should take in a version number plus payload. And then for version 1, the payload would be the period number. Of course, well, at least initially that would basically be hard coded to 0, because other periods just don't exist. But like once we do state expiry, it'll be the period number.
Am I understanding correctly, Alex, that the first byte determines all of the subsequent bytes? It just so happens that version 1 only has the first 4 reserved.
Yeah.
But like you could have version 10 that the bytes don't mean signature at all.
Yeah.
Yes.
But there's also like an entirely different option. Instead of EC recover returning an address, it could just return a public key. And then you can generate whatever format you want out of it.
So how does this work at all with legacy contracts? Like there are legacy contracts that call the current EC recover with the current parameters, and they need to continue to work. And so if you have signature, I guess we just map it to the compressed address always. Is that correct?
The problem is that doesn't work because you don't, like, from a signature, you can't see if it came from a long account, because there's no such thing as a signature from a long account. It's just a signature from a private key, and the private key has corresponding legacy accounts and corresponding long accounts. So you just can't, there's no way to resolve a single signature of the old format to one of the multiple accounts.
So all
That's just not a thing. You can't.
All what EC recover does, it just returns a public key, and we decided that we format that public key to be an address, right?
But the problem is it can't, like, you could do that with the new opcode. You can do that with the new opcode. Basically, you change the behavior, but like EC recover for existing context at least would have to continue to return this 20 byte like shortened version of the public key, right? You can't make the behavior of the existing EC recover, at least when called from the legacy.
I'm not suggesting to change the current one for legacy context anyway.
But I think we're talking about two different things here. Can we focus on one or the other, either EC recover and how that works with legacy contracts, or EC recover and how that works with new contracts? I think those are two totally separate questions. Which one do we want to talk about?
For legacy ones, the current precompile address, well, you definitely cannot change what it returns. But the second question is whether you can change, whether you can extend the input to influence what it returns.
Not for legacy contracts, because they're already deployed.
Well, legacy accounts will continue to be deployable, right? So you can deploy new bytecode.
Sure, but I'm saying, like, there are many contracts out there that use EC recover today, and they have code already deployed to mainnet, and those need to not break.
Right. What you could do is you could add optional longer call data that you send to it that just no existing contracts do.
Whether you can extend the input or not. And I haven't
we cannot extend the input. Yeah, we definitely cannot extend the input because there are contracts that exist. You cannot change those contracts. They're immutable.
No, but
they're
extending
out there.
the input,
they're expected to work.
No. Now, to clarify, extending the input doesn't mean that now you require more bytes always. It just requires that you may accept more bytes and treat those more bytes somehow.
Sure.
Right.
Sure, but the whole system still has to work when a new account is using a legacy contract that does not pass additional bytes through to EC recover. So like everything needs to work with like an Epoch 10 account.
That's not true. Like if an Epoch 10 account might just not be able to use the legacy contract functionality that requires signatures.
So right there, that goes against one of the precepts or the assertions we said earlier, which is things need to transition smoothly. People need to be able to create new accounts, and they should still work with legacy contracts. Like this is a pretty big deal to say new accounts will not work with legacy contracts that accept signatures, because there's a lot of them.
Okay, then stop here and let's talk about this, because I don't think we have a way of fixing this.
Sorry, Sorry, Peter, go ahead.
So, like, can I point out that if you look like on the really broad spectrum of like what's actually planned for Ethereum, I think like EC recover that returns an address is just going to get more and more conceptually broken, because to start with, you can only EC recover if the address you want to EC recover to is an ELA. if the thing that you might want to EC recover to is a contract, there's no you can never like produce the private key that EC recovers that contract. As I understand it, the long-term plan is simply that we're going to get rid of EOAs entirely, and everything is going to be a smart contract, and we're going to have this whole account abstraction system. And at that point, like EC recover will become, in a world where EOAs don't exist, EC recover is like completely useless. So I'm like, a lot of people are getting confused about, well, the fact that changing how addresses work is going to break EC recover. But I'm like, are we sure that EC recover isn't in the long term going to get broken? And if so, does it matter that EC recover doesn't work with long addresses?
So I think you have a point. But at the same time, though, I think you underestimate how willing people are to kind of have hacky backward compatibility solutions. So even if we were to move completely away from EOAs tomorrow and replace them to on-chain implementations of contracts that do the same thing, basically, we would have a hacky kind of like patch for EC recover that what it would do is it would just kind of like recover the private key and then convert that into an address, and then just continue to send that, like maybe call into that address to see if the implementation changed, so it doesn't want to accept like that type of private key anymore or something, but still return that. So even in a world where these are smart contracts, there would be this special backward compatible EC recover, while we would move to a new form that would be more active, where you actually send the address and then it calls the address and lets it do some signature check or whatever. So I think in the long term, we'll definitely have to move to an opcode anyway that takes in the desired address. And so that actually, now talking about that makes me more kind of open to Alex's proposal of like a new EC recover that actually takes in the address that it expects instead of only some kind of hints of that address. So actually, I think that makes more sense now thinking about it. That's more forward compatible with the kind of abstraction. But the existing EC recover, the more we can keep that not broken, the better. And as Micah was just saying, like, it's actually that was one aspect that I just wasn't aware of. It is really hard. Like, you'd have to do some really weird address, like basically access list trickery in order to make EC recover compatible with this new world of multiple accounts, on-chain accounts with the same private key, or same public key even, right? So this is actually, so it's independent. I feel like there's that, we have to talk about how to design EC recover too. And I think I'm now on board with Alex of like it taking in the expected address. I think that's a really good idea. But the other one is, how can we make EC recover be maximally useful, continued for legacy contracts? And there, I think it's like a really hard challenge. How can we make it work with long address UAs? So I feel like that's what we should focus here.
So I just, before we go too far away from that, I do want to clarify something with Peter. Is the plan that with the transition to everybody's a contract, does that actually mean that EOAs, or sorry, there is not a private key that maps to the address that is your contract? Like, I think there's some proposals for account abstraction where your code for your account would live at the same address as your EOA recovers to. So you could assign things from a contract account.
No. Well, somewhat. So basically, by default, existing kind of like EOA style contracts, we would also, of course, have the Ethereum object format maybe or something like that. So you, instead of having one code, you basically have like a signature verification code and a kind of like with these kind of bits, right? And then like basically the signature verification code by default would indeed continue to do the check against the private key that maps to the public, that has the corresponding public key that maps to the address. But you could override that, right? So you can upgrade your EOA to no longer return, like basically no longer validate signatures that way. And so you could end up with like an EOA that was upgraded. And so it now no longer is able to sign things from that private key. Now maybe it does some other things, some multisig or whatever. So by default, yes, but not forever, I think.
So, and just to counter Peter's point, I think that means that the vast majority of people, which means contracts will be created that allow for signatures that they want to recover.
but even account abstraction contracts, they may elect to use EC Recover to do the internal verification. And EC Recover can not only be used with actual accounts, it can be used with any kind of signatures. And I'm sure that there is someone who is using it in such a way. In fact, I used it in such a way like in 2015. It certainly is possible.
Wallet and 0x both do that, don't they? Like, they don't actually care if you have an account. They just need to make sure your signatures are valid.
Yeah. And just going back to the very beginning, I'm not sure how we really drifted away into all of these different directions. But I think one thing, Micah, you said, and I tried to present one position on that. Okay, maybe let's just clarify that EC Recover for legacy account, it still has to be able to function the same way it does today. But there's one question: can we extend the current EC Recover precompile in so that it accepts more bytes as an input? And if it does accept more bytes as an input, can it safely interpret any bytes after? Currently, it takes, I think, like 4 words as an input. So can we say that any other data after those 4 words could be, like new flags or any kind of configuration to have a different behavior? And I checked I haven't checked every single client, but there doesn't seem to be a validation on the input. So it seems that they can accept longer inputs today. I think we yeah, but I think we only have specific rules on some of the newer, like BN128 or the proposed BLS precompiles to have an error condition if there's more data than expected. But we don't have that for EC Recover.
But I don't think this helps here at all, because whatever added benefits you get from that, you also get from an EC Recover 2 opcode instead, because it's only useful for new contracts that are aware of this. Existing contracts, they will continue to send the short input to it, and so they'll it doesn't help them that now EC Recover can do more things because they can't use them. And so, and new contracts, if they use this extended EC Recover or if they use an EC Recover 2 instead, that's kind of like, it doesn't matter for them. And so I feel like I
still had a few words to say on that. Is that
sorry?
So we don't have a condition which rejects any input which is longer, which means I don't think we can actually extend it, because currently there may be contracts which send more data out of any kind of bad programming reason. And if we would accept or treat those bytes after 128 in a different way, that may be breaking. But to reflect to what you're saying, that they cannot, the other, I guess, long-term discussion regarding precompiles is people are just afraid or annoyed or just don't like ending new precompiles. And that's the only reason why anybody could consider extending the existing EC Recover as opposed to introducing a new one.
I suspect you'll get more pushback from the core devs on changing the behavior of EC Recover than you will from adding a new precompile.
I think that was Alex's point. So basically, because people will be reluctant for EC Recover 2, looking into can we extend EC Recover. Right now, it looks like this might not be possible, because if there was no validation, then there could be kind of incompatible existing behavior. Okay, I understand that, but I feel like we all agree, basically, let's try and, because we're getting close to the end, probably trying to kind of summarize that specific point. We all agree that in a future world, basically there would have to be an EC Recover like precompile, be that EC Recover itself or a new one that takes in more extended information, be that the period number, be that the expected address, whatever, kind of like that's TBD, and then does its thing, basically. So like the exact details, like extending the existing one, doing a new one, that's basically that would have to be worked out. At the same time,
my vote is EC recover 2, and if someone pushes back on that, we can fight them a little bit, and if they really push back hard, we can fall back to updating EC recover 1.
So I guess now we can come back to the first question on there, which Mike, you said, why cannot we just do that? First question was, should the precompile just behave differently based on what is the caller address, whether the caller is...
I'm convinced on that. Yeah. We don't, that's I'm convinced we shouldn't do that.
Great. Yeah, I just wanted to go through these different options. The clearest to us seems anyway to have a new precompile, which has clear and new rules. Just really wanted to validate that. Yeah, I wonder if on subsequent calls we can be maybe a bit more focused on any of these questions, because I think we just really started to really discuss 15 different aspects of this and not going point by point. It took maybe longer to arrive at the end.
I think I suspect the problem might be that will help in future calls if we resolve is making sure we're all on the same page for what our goals of these calls are. My personal goal, which maybe doesn't align with you guys, is to become convinced that address space extension is something we can do reasonably. We can actually get this on chain. And right now, my biggest blocker is what I just realized with EC Recover, that new addresses will not work with any existing contracts that do EC Recover. That's about all the things on here. Everything else, I'm kind of convinced, yeah, there's solutions. These are solvable problems. That one feels like it might block this whole project to me.
That you always get.
I don't know if you guys have similar goals or not with these calls.
So what you're saying is that with keeping EC Recover intact, you will always get back a legacy address, even if somehow through some UX error somebody signed a message, or it doesn't need to be a transaction, but some kind of a message and sent to a legacy address, but they used a new long address to do that. Right.
I don't think
that's another UX issue.
Issue.
The issue is that someone uses a contract where the EC Recover is used sometimes, and sometimes message.sender is used. And if those two things don't map to the same thing, then you have a problem, because the user, deposited some money from message sender, and then they tried to get the money out using EC Recover, and they recover a different address because the one they deposited with was a compressed long address that's from New Epic, and the one they recovers the legacy one, and they don't match, so you don't get the same address, and therefore their funds are stuck.
Right, I agree with that assessment. So yeah.
Can I point out that this is already a risk if you say user Gnosis safe and send an account to deposit some money with, say, a smart contract like Gnosis Safe into an account, and then only later discover the way to get it out is to use EC Recover?
Yes,
that's fair, but I think we have the same problem in reverse as well. So you put the money in using EC Recover, and you can't get it out the other way.
Right, but
that's a good point. So the way I described is already a problem. However, if you invert it, I think that is a new problem, because you wouldn't be able to get the money in the first place when it was safe.
I don't think that's so. I feel like there's two things here. I don't think we have to worry that much about stuck funds. The problem is it just completely makes these kind of systems incompatible with long addresses, and so people would just not ever move to long address UAs. If I want to continue to be able to interact with legacy contracts, and some of them even, I don't know, die or whatever, right? I can, there are functions that accept the signature and validate them and do something with it. And some DeFi systems depend on that. So there's no other way to interact with the system other than via these signatures. And I just completely cannot use, I'm sure all of these systems would have protections in place that would just say, sorry, you're trying to interact from long UA, that just doesn't work with our system. you're out of luck. But that's not so. I'm not, and maybe the odd one would let you through, and then the funds are stuck. But I don't think the big problem here is the stuck funds. The big problem is just that like our design goal was make it be fully backward compatible, and that's just not backward compatible. Like this is a type of today legacy kind of functionality that you cannot use and cannot interact with as soon as you have a long EOA. And so this is something we have to find a fix for, basically. And I mean that you can trivially find fixes, right? But like I'm not sure they are good enough. So for example, what you could do is you could have a new transaction type that adds basically hints, right? So like you basically say you include a mapping of, and it could even be signed by the key. So like you'd have to include a signed mapping of like, please my public key, please map that to a long address with period number, whatever. And then whenever EC recover as part of the transaction is hit with a signature like that, then it uses this mapping to determine which one to return. This would work, but of course it looks really messy and who knows what kind of implications this has. But this is the type of solution I would want to look into here, because I'm in a similar boat with Micah. I feel like maybe like kind of expectation wise for these calls, like my primary expectations for now, I feel like in the stage we are right now, because it's not like we have to make address space extension work. It's like we have to decide if we want to use address space extension for state expiry, and otherwise address space extension will probably go back to the dormant state of let's solve this 5 years from now. And so my primary goal is figure out how feasible address space extension is. So if it's worth continued focus. And I hope I really, my hunch is the answer is yes, let's do it. But I feel like basically specifying exactly how an EC Recover 2 works is less important than figuring out is EC Recover like an insurmountable kind of problem anyway. And so, yeah, that's why I feel like these kind of questions are the first ones to answer. To address.
I think you oversimplified that. So if we wouldn't have discussed like EC Recover, we wouldn't have arrived at this, at least not today, that this is yet another one of those UX issues.
Agreed. I wasn't aware of this. Like before, like 20 minutes from now, I wasn't aware of this problem. So like the only reason I'm aware of it now is that you kind of had this point in this document.
Yeah, so I think the points in the document, I think what I was trying to get at least with my goals for these meetings, is that for a number of these points, like you have questions on here, but it's not a question of can we do it, it's just a question of which solution do we choose. And I don't care at the moment, at this stage, I don't care which solution we choose. I just want to know that there is a solution. And so for example, for the EC Recover one, whether we do a, EC Recover 2 or we extend EC Recover or all that, doesn't matter to me. Like there is a solution, we can move on. Like that's why I keep kind of pushing us away from focusing on like the minutia of like some of the specific bullet points, because I feel like the bullet point already just says, hey, here's the answer. Like here's a solution to the problem. And then at that point, like I'm ready to go. I'm ready to move on. And I get the impression that maybe not everybody here is on that same page. Like I think we might be, that's why we're kind of running into conflict with how we progress, is because I think some people maybe want to kind of figure out the specifics of how do we solve each of these problems specifically. And that, I just, like I said, I don't care about that right now.
Just to reflect on EC Recover specifically, I think the goal was exactly what we did, figure out whether we can change the current one to have different behavior based on maybe the sender or the inputs, and if you can, then what does that mean? If you cannot, what does that mean? But the goal wasn't to whichever we choose to fully specify everything, but just to discuss whether we can change it or we cannot change it, and what are the implications in each of those cases. And that's exactly what we did, and I think that was really useful.
Yeah, I agree. Actually, that's what I was trying to say. Just like I feel like it's unfortunate if people come away from this with like saying, "Oh, we didn't get anything done because we jumped too much in topics." I think some of that is true. We jumped a little bit much, but at the same time, I still think I'm kind of, at least subjectively, have the feeling that we move closer and closer to the answer of, is this feasible at all? Like, should we go ahead with address space extension? And by going, and I think I still think that this document is like really like perfect, like for exactly this purpose of like triggering all these discussions. Yeah, but I think it's actually productive, even if it maybe doesn't look like it. I don't know though. I just wanted to kind of like counter this kind of this impression of that we're not being productive. But yeah.
Yeah, it just felt like in the beginning, when we spent so much time on the collisions, but that was also useful. But to reflect on the transaction idea, I think we had a similar idea either through the transactions or maybe through some kind of a option in the translation map. But yeah, I guess we should have listed the question whether accounts like private keys should be able to, and how should they be able to, I guess, interact with the network with each of their personas, and the persona is, whatever addresses they can resolve to.
I like the idea of anywhere in the system where you are, so basically whoever signs a transaction or maybe signs a payload that's embedded in the transaction, that signer can dictate how all the various functions, like what the various functions will return. So the EC recover is the easy example, and this is what basically Ansgar was getting at, where whoever has the private key that's signing over this data, that's opaque to Ethereum because the contract's all that knows about it. But we can have that same private key sign a thing that says, anywhere in this transaction, if something tries to EC recover my private key, or sorry, something tries to EC recover to my address, and the signature lets us know what address that is, I want you to explicitly return this value, like, and where this value is one of, like, your legacy or your Epic 1 or your Epic 2 or whatever. So that way we basically give the control to the signer, and it'll take some UX work, but no one will get stuck funds, and people can continue to interact with new addresses with old contracts.
Yeah, probably the only okay, breaking up that two parts. So part one, I think is clear cut. It should pose no issue that a transaction from an EOA, it can decide which persona it wants to interact with as. So like any of the legacy address, or whether any addresses in any given epoch. There doesn't seem to be, at least right now, any risk with that. But the second part is the compressed address, whether they should be able to use the compressed address as a persona as well. And that's the one which you may need to solve some of these UX issues.
But I think that is somewhat different, right? That basically was the question of like, should they be allowed to send transactions from their compressed, like they basically look like they come from the compressed address. Yeah, suspicion is no, but like maybe there are reasons to allow this. But I feel like that is somewhat separate from this EC recover question, though, right?
No, it's not about EC recover. It's just in general how they can. It's transactions. Yeah, it's not EC recover.
In general, it'd be nice if we can just blanketly say, when you sign a transaction, you can specify as part of that transaction, the data you sign over, that this is the address that I'm going to be interacting with this transaction from. Like whether it's your Epic 1, Epic 2, or your personas was a good word for it. I would like to, I know everybody's trying to get out of here, so maybe in the next meeting, I would like to explore more why we can't just treat their compressed address as yet another persona that they can act as. Like, why is that problematic? I think you went over it before, but you don't have to go over it again now.
Okay, yeah, I think that sounds like a good agenda. And I have a related question to that. So I have a few more points I want to add to the document. And I was wondering, should I just add it to this document? So it's kind of like a living document, or do we consider it like kind of locked in so that we can
I think I like living document personally.
Same.
Keeping this as the canonical source of all the known issues. And then maybe even as we come to consensus within our working group as to which solution we like for some of these, we can maybe also note that in this document. And we'd still keep the other options and everything, but like if we decide, amongst ourselves that, hey, we think this is the best option, it'd be nice if we added that on here.
Yeah, maybe for decisions, we can have like a separate chapter just saying it or whatever, or inline, I'm not sure. But just for extending it with maybe new discussion points, I guess that's fine, as long as it's like just adding a new point in each of the sections and it doesn't changes anything or shuffles anything, right?
Yeah, as long as kind of like it's obvious which ones were added. So like if I look over it and like it's not just one line completely in the middle of some paragraph that I didn't like, right? Because then I won't see the change. If it's
no, I think just
like
we can only add like new points, and
yes,
we shouldn't change anything else, at least not now. So like an app and only your points.
Does StackMD not have diffs?
It does have diffs, but
it does. Yeah, it's a bit weird in how that works.
Oh, but actually I can save a version and then you can do a diff between the different versions. That may work.
Oh, nice.
But yeah, anyway, do we want to set up a time for the next call?
Yeah, that would be my question as well.
We have I have all core devs tomorrow at this time, so I guess we can do this right before all core devs if you guys really like talking.
Yeah, I would suggest we go with Monday, because then Pavel gonna be back as well, and yeah, so far he missed these meetings.
Monday's fine with me.
Same. Would that be the same time then? Like, just stick with this slot forever, unless reasons otherwise?
So for me, ideally, maybe just I have another meeting, but I guess I can skip it. Yeah, ideally 1 hour later would be, or maybe 30 minutes later as a starting time would be the best for me. But if it's only me, then I will just shuffle that existing one around.
I can 30 minutes flexible. Later I can do.
Should we maybe try and aim for like should we stay with like 1 hour, because we're always running over anyway? We go to 90 minutes and then try and stick to that and not run over or something.
I suspect maybe we'll run over.
Yeah, maybe it's good to keep it 1 hour and then we run over like 20-30 minutes. But if we do like 90, then we're going to be in 2 hours. And
okay, yeah, that sounds good. So if you guys want to,
we could shorten the meeting to half an hour, and then the meeting will only last an hour.
Yeah, but then we don't get anything done. So yeah, if you want me to, I could send out like an invite for Monday for 30 minutes later than this slot. That sounded like that's what people were kind of getting to.
I mean, that would be the best for me, but yeah, I mean, it's many more people than me on this call.
Sure, but unless anyone has any preference, it feels like why not go with yours?
30 minutes later is fine with me. If that's better for you, then I have no problem doing 30 minutes later. I could even do an hour later. Beyond that, it's starting to get pretty late for me. So 30 minutes or an hour later than the current call is fine though.
Yeah, let's do it 30 minutes later.
Okay, sounds good. And should we continue to just send? I mean, I don't mind too much sending it out to everyone. It's just I'm always a little bit afraid that it might annoy people, but I guess that's the price to pay. And there might always be 1 or 2 people who haven't been following so far who would like to join for the next session. So probably best to keep.
I'm fine with sending out to whoever's interested. Just make sure it's clear that we're not going to go back and review old things. Right. It's not in depth. Like you'll get the very, very short version if you're not caught up.
Sounds good. Pooja, just a quick question. Like, what's the timeline for publishing these calls? Will they be like available before Mondays so that we could just have that in the invite for like people to go and have a listen?
Yeah, generally it is within 24 hours. I mean, like I did it like 3-4 hours. Sometimes Zoom takes time to process it, and once it is done, I'll upload it directly.
Okay, that sounds good then. Then we can just do that, and well, I think then I'll just wait with the invite until that's basically done. And so once there's a YouTube link, I'll kind of like put that in the invite for people, because there's like several days. So I think it's more feasible for people maybe over the weekend to catch up, the 1 or 2 people for whom that is relevant. So then we can have the YouTube link in the invite and tell people.
And I can also, And I can also share the YouTube link in the state channel if that is helpful.
Yeah, that sounds good as well.
Okay.
Awesome. So then that's probably a good kind of stopping point here. Or anything to discuss for today?
Not to discuss, but do you want to set like kind of an agenda for the next call? And
right,
Micah proposed that we maybe discuss a bit the transactions and whether you can take up your compressed address as a persona. I think that would be a good topic.
Yeah. So the two things I would like to discuss are: is there any problem with personas in general? Like, can we just do that, and can that maybe solve a lot of our problems? And then, if not, are there problems with allowing for compressed addresses as a persona as well?
Right, and then I would want to maybe extend that, and like because I still think that kind of talking about this EC recovers thing in general, like and specifically makes sense, but not like just the backward compatibility. So like, is it like is it feasible to also allow like accounts basically to control which persona existing signatures resolve to from legacy contracts via EC Recover? So like, just, I mean, that kind of seems to also fit this persona kind of conversation. So like, how much control can we give private keys about like how the system interacts with their persona? Like, I don't think it makes sense to just implicitly do that. Like, if you send a transaction from a specific persona, then every signature from that private key also resolves to that persona. I don't think that makes sense.
How about we just set the agenda? And let's just say that, you know, the personas and transactions and backwards compatibility is the agenda.
Well, and one last thing, maybe if we have time, I really think we should at some point have a session on or at least have a session on the translation map as well. Like just the pure kind of like, how is it stored? Does it expire? How much size does it take up? Because I feel like that's also a big blocker that we kind of so far have only barely scratched. But I'm not sure if we get to it on Monday. Just like, if we have the time, that's a big one that I really want to talk about.
Well, I hoped, but because that's like the one part of it, the transaction access list is like, it's quite a big topic. But yeah, I think it's unlikely that we're gonna get that far. The persona stuff may take quite a bit.
Yeah, sounds good.
Okay, so agenda is personas and all the ways they can be used. And then if we get done with that very quickly, then we'll move on to access lists and transaction maps.
Sounds good.
Cool.
So
thank you all.
Thanks everyone.
See ya.
And talk to you on Monday. Bye.
Bye-bye.